Hello, everyone, and welcome to Elektor Lab Talk number 36. I'm Brian Tristam Williams, and today we're diving into the latest edition of Elektor Circuit Special, a celebration of clever, quirky, and occasionally chaotic electronics projects from our community and our editorial team. So we've got a great lineup for you today. We'll be looking at standout circuits, talking about what's currently on our lab benches, and even tackling the bigger question of how circuit design fits into today's energy challenges. So joining me are some familiar faces. We've got Clemens Valens, Elektor engineer and resident neon addict. Clemens, how are things in France today?
No, I'm fine actually.
Great.
The weather here is cool.
Been having a hot summer up north. And we've got Saad Imtiaz, whom you know. He's our senior engineer in Elektor Labs, and he's always building something ridiculously cool. We're hoping to have Jens Nickel, our editor-in-chief, but he's having some technical issues, so bear with us. Saad, how is Pakistan today?
All good, very rainy and cloudy, but it's getting cooler after a hot summer.
Nice. It's still winter here in South Africa, a bit chilly, but luckily we have energy, which we can talk about later to do our heating. But before we go on, let's talk about our giveaway. 2 lucky viewers today stand to win one of these each. First up, it's the Neon Lamp Dice kit, as you see there on the screen. It's designed by Clemens himself. It's got real neon bulbs, safe onboard high voltage supply, and just the right amount of retro glow for you. Second, Clemens has also just put out a new book, very productive, Clemens, From Rubbing Amber to Swiping Glass, which traces the wild journey from static charge to smartphones. To enter, you just need today's code word, which I'll give you later, as always. I'm checking if Jens is able to join us yet. Not yet. But let's talk about our sponsor today. And we thank them for sponsoring us. It's Peak System. It's a German company specialized in hardware and software for CAN bus communication, which originated in the automotive industry, but is also widely used in industrial and medical applications. Peak offers a wide range of products, including CAN interfaces, I/O modules, data loggers, diagnostic handhelds, and development tools tailored to the needs of development, service, and test engineers. So if you're building or debugging anything with CAN, definitely check out their lineup at peaksystem.com. That's peak-system.com. Okay, guys, I guess we can jump right in and say hello to all of the people joining us in the chat. See, Frank DeHat was there early, as always. Joseph Souza from USA. We've got UK. We've got Germany, France, Belgium, Cornwall, UK, the Netherlands, of course, Vlaanderen, Istanbul, Black Forest, and Germany. I could go on and on, but thank you, everyone, for joining us there in the chat. Shall we take a look at the circuit special, guys? Quite a nice cover, I think we've got here for our August bonus edition. Packed with detailed projects, as you see. And there's Clemens's Neon Dice, which features quite a bit in this. In the middle there, you see a Simon emulator. You remember the game Simon from the 80s? That was pretty cool. I enjoyed that. But taking a look at the table of contents, again, I told you Clemens is famous. There's his Neon Dice. Hopefully later we'll be able to talk about this ESP32 audio transceiver board. And yeah, just take a look at that table of contents. There's a lot in here. I can't read it all out loud. We will touch on a few of our favorites a bit later. So there's the cover, there's the table of contents. Now, we were going to speak to Jens about his favorite projects, but we'll skip ahead to Clemens so he can tell us about his Neon Lamp Dice and the article as well. So Clemens, what inspired you to go for neon? Is it just retro?
The sound is really bad. I can't hear you. I hear vaguely something about the neon lamp dice, so I think you are talking about it.
Yeah.
It's a circuit based on an old 1960s, 70s ring oscillator design based on neon lamps. So I created it. I used it here on my on the board. You can draw it as a circle. I don't know if you can hear me. I'm just blubbering on.
I can hear you.
I can't hear you, so. But because this is just a blinking, just an oscillator with LEDs, with neon lights, I decided to make it a little bit more complex. The fun part of this oscillator, this ring oscillator, is that it is never oscillating in the same way. So it is not following a fixed pattern. It's a kind of random pattern. And so I can see it now. So I'm talking about this bit here. So this is never oscillating the same direction. Where is the power switch? So here you can see it.
Nice.
And because it is oscillating randomly, you can use it as a random generator. Where is the button here? So as soon as you press this push button here, the oscillator, the state of the oscillator is sampled and it's converted into a dice value. So this is the value of 4, 3, etc. And to make the dice in the same way as the oscillator, it's also made with neon lamps. So for this, all we need is here. It is the high voltage power supply that delivers just enough current for these neon lamps. So as soon as you put your finger on it, it will collapse and nothing will happen. Well, that's about it, I think.
Well, Clemens, can you hear me now?
Yes, now I can hear you.
Okay, great. I'm just curious why you chose neon instead of the easy way out, LED.
Well, because I started with this neon ring oscillator. There you have it. And once you have neon lamps, then it's a bit. Well, I like to stay in the theme of neon lamps. I've gone to LEDs, of course, but that would be less. There are so many LED-based dice on the market, so that's why I opted for the neon lamps.
Like you said at the beginning of the article, LED light is cold. Even if it's warm LED, it's just not as cool as neon. Yeah, so a reminder to our audience that you stand a chance to win one of these. And I wouldn't mind winning one of them myself. It looks pretty cool.
Yes, and we can add about the circuit. The design, it's in this Elektor Classic format. So it has the layout of the circuit is in such a way that it looks a little bit nice. The stick is also on the board, and on the back of the board you have the description of the circuit. So it's an article at the same time.
Yeah, it's a physical hardboard article. Yes, we have a few Elektor Classic circuits like these which have been brought back to life or reinvented. And yeah, it's a nice display piece. As you see, it goes there in the wooden stand, and you could have it up on your mantle, and it's a nice conversation piece. So I will give the code word for the competition later, and good luck to those of you entering. Now, we seem to have a little bit of glitchy internet in Europe today, surprisingly, but Jens is joining us. Jens, can you hear me? Nope, Jens is frozen. So, but Saad and I are working surprisingly well. I guess we'll move on then. Let me talk about an article I like. Mine would be, I've got a couple. I mean, it's a big edition, but when trying to tune one of these, my daughter's violin, I was trying with a manual tuner and I snapped one of these strings. So that didn't work out too well. And along to my rescue, yeah, there's the violin. We can just show that again. It's sort of a cheapy one, but Dad was the first to snap my daughter's string. So yeah, I've got to fix that. But to my rescue, instead of using a neon, we've got a violin tuner with the AT Tiny 202. So I like this article because it shows you how you can squeeze out of a tiny low-cost microcontroller like the AT Tiny 202 with just one port pin, no digital to analog conversion, and a bit of clever phase accumulator logic. It generates precise musical notes, and as I said, it acts as a violin tuner. Where are the notes that were here? There we go. It's got G, D, A, and E, and it's generated via the phase accumulator. So it's a great example of doing more with less. And the simplicity of the circuit makes it super approachable for beginners who want to explore interrupts, timers, and DDS style signal generation, and maybe save on violin strings in future so you don't have to sit and try and do a manual tuning situation. Clemens, if I can come back to you about your book. Let's have a look at this now. We showed a bit of it earlier. There's the cover, but we've got a preview here. You've been very productive this year, Clemens. How long did this take you to write?
Not that long, actually. I started in, I think, last October, and it was finished in February, so that's a few months.
Well, I see there's a whole bunch of stuff there, and the audience can see that too in the table of contents. But can you give us an overview of it?
Yes, well, the book is intended not as a teaching book, a study book, to learn electronics, but to learn about the history of electronics, more or less, and about the important themes, the things that are important in electronics. So what makes up electronics? And of course, the book talks about the transistor and the resistor and the capacitor and all that stuff. There is also a chapter about, for instance, feedback, because feedback is a very important theme in electronics. Similarly, there is a chapter about PCB design and wiring that's often overlooked in electronic design. And so this book presents all the important themes. So if somebody doesn't know anything about electronics, you could have a look at this book and then understand at least the big themes. It's sometimes a little bit technical, sometimes it isn't. It's full of interesting facts, useless facts actually, that are good for in bar and in dinners where you need conversation material. And so it's we call it a coffee table book. It's a hardcover book with lots of nice illustrations, so it looks really nice. And it has also, which I find very important myself, it has a very extensive index, an index of all the people that are important or were important in electronics. So all the inventors and theorists and mathematicians and all those, plus a list of inventions and terms and discoveries. So if you don't know what something is, then you can almost use this book as a dictionary and look it up to find out what the word means, what it refers to.
Well, that's great. I'm looking forward to getting my hands on one because having studied digital logic, I just kind of skipped right ahead from Ohm's law to digital stuff. So I don't really know how a transistor works, or especially how a vacuum tube works. So,
yeah, well, this book doesn't explain how these things work. Huh? It just explains what they are and how they came about, where they came from, and why we have them, and why we don't have them anymore also.
Well, that's a great first principles, and first principles are always important. I like your Elektor logo there.
Yeah, so that's the Crookes tube. That was one of the inventions that led to the discovery of the electron.
Very nice. This is just an overview. Of course, I don't have the full book at my disposal here, but I wouldn't want to give it all away anyway.
I have it here.
So, Clemens.
Of course, I have one.
Yeah.
Of course, also available as an ebook, but an ebook, ebook doesn't have a hardcover.
Not the last one I saw. Look, I prefer the printed book. I love having them on my shelf, but an ebook I can get immediately from the Elektor store website. So that's pretty cool in itself. Sometimes nice to have both, but then you have to pay twice, which I'm not a fan of. Jens, how's your internet? Are you able to join us?
We can
try it, Brian. First, I have to apologize. Can you hear me?
Yes, yeah. I can hear you.
I have to apologize. Maybe that is a sign that I should stay at home next time.
Well, no, don't
Yeah,
apologize.
but okay, I can also say something.
It's not your fault, Jens, so no need to apologize. Something weird about the internet.
Now you are frozen.
I can act frozen, but I'm actually moving, so I think we'll jump ahead. We've talked about the violin. We've talked about...
Can I say, can you hear me?
I can.
I would like to, can you show the cover again? Because
sure.
If you scroll down a little bit. So yeah, I think we've done this before at the Elector, that the person who's reading the Elector is reading an Elector with himself on the cover, etc. So it's an endless repeating image. And beside it, you see this can, een Droste can. That's for Dutch people a very famous, because that's, I don't know if it's the first one, but that's the main inspiration for this kinds of illustrations, because on the Droste can you have this woman, and she is holding a Droste can, and on which she is depicted herself holding a Droste can, etc. So that's a kind of a little wink to the cover of Elector, but I think only Dutch people will understand it.
Well, we had something like that on coffee cans in South Africa back when I was a kid. You're just reminding me now. It's one of those memories in the recesses of my mind. But I like this, the way it's done on the cover, the theme of recursion almost, when you're programming and going deeper and deeper into a loop. Now, to Saad, I want to ask you, Jens wanted to talk about this circuit, about power banks in parallel. Obviously, he's having some glitches there. But if you put them in parallel, you can get a 3-day continuous power solution. And you can connect them parallel or serial, right? You can have higher voltage or more amps, or should I say amp hours available, correct?
Yeah, if you connect them in parallel, of course, you have more amp hours, but you cannot connect them in series because it's a USB connection. So the best option will be that if you get the battery separately and then a boost converter to use it if you want a higher voltage. But yeah, this is a really good circuit. Johnny also published, I think in the last edition, it was a stay alive circuit. And as you can see inside this PCB, it houses 4 of those circuits all together. So it's basically a stay alive circuit and keeping everything in parallel as well.
So when you say stay alive circuit, you mean like you get some power banks where if the current being drawn is too low, then it turns off.
Exactly. So normal power banks, if the current consumption is very low, they turn off themselves to save power. So Johnny made a 555 timer to generate short pulses to keep all of those power banks alive at the same time, and also with some of load sharing and these problems aware, because if you use all of these power banks all together, then you have voltage mismatching and then current backflow, uneven load sharing, and then one power bank starts working more than others, then the other turn off. So he used the low drop diode modules to prevent backflow, and then generated the short pulses from the 555 timer to keep everything alive. And yeah, with some magic, it becomes a big battery pack, 3 packs.
Well, I see that the data lines are not connected. So would that prevent you from using fast charging or USB PID?
I believe, yes, of course, you will, but he can, right now, I don't think so. He covered this in an article, but you will get 5 volts and 2 amps at max, because that's already programmed. Yeah. But these days there's this PD chip out there, which you can control, even make your power bank into a power supply output with controlling the voltage, but that's something different. This is something simple and to connect everything together.
Yeah, well, I've got my phone on charge right now, and I know that I often use Raspberry Pi power supplies because the new ones have the PD, and it can go up from 5 volts to 9 volts to, I believe, even if you want to charge a laptop, sometimes even 19 volts.
Yep.
So shall we talk about power, since we are talking about battery backups?
Start about the serial.
Continue, Jens. There is a bit of a delay, but
Start
I'll
about the
be
serial
quiet.
connection. Wouldn't it be possible to switch power banks in serial with a similar approach, also diodes, and keep a live circuit? Because if you, for example, use a boost converter from 5 volts to 20 volts, you would have a very low efficiency. I think around 50% or
Yes.
something.
Yeah, you're
Maybe-
absolutely right. If you use them in
Maybe we could
series, then-
investigate that, because I would have an application for. You may know. Okay, you may know that you can't transport power banks which with more than 100 watt hours in a plane. And for example, if you want to have 20 volts on holidays, then you could use normal power banks and for normal power banks and switch them in serial together.
Yes. So if
So,
we don't use the uh, if we use the power banks by itself and then take the 5 volt from the power bank each and make a series connection, that won't be possible, because it will make some ground loops, and as the circuitry involves going through a boost converter, I don't know. I don't think it will be reliable to have them in series. So as we discussed before with Brian, that if you take out the batteries or remove the circuitry of the power bank and make your own to boost it up to 20 volts, I think that would be much more easier to do.
okay.
I'm giving Jens a gap intentionally because there's a heck of a delay coming from that side. I want to talk about power and the mains grid. I think it's relevant to me and you more, Saad. Although our internet is great today compared to Europe, but we tend to have some power grid challenges. Now, I've been doing some Googling on power costs around the world. And look at Ireland at 45 euro cents per kilowatt hour compared to, say, South Africa, where I am. It's about 13 cents a kilowatt hour. And up here we have Germany at 40 cents, more or less, and France at 28 cents. And I'm wondering, maybe I'll ask this to Clemens. Clemens, you're in France, Jens is in Germany. What if you live on the border and your neighbor is in Germany and you're in France and you're paying 28 cents and your neighbor's paying 40 cents? What's to stop you from just running a cable from your neighbor's house and contributing to his electricity bill?
I have no idea. Maybe the law.
Perhaps EU regulations. And then Saad, according to Google, you pay about 7 cents per kilowatt hour. I'm sure if that's accurate.
Pretty much. It actually, we have something called peak hours and non-peak hours. So right now the peak hours just started. They start from 7 p.m. to 11 p.m. And throughout the year they change by an hour or so. But throughout the day it's a flat rate, and it's pretty much the same for the entire day.
Yeah, I don't know how they calculate that, because in South Africa, whether it was 40 years ago, we just had a kilowatt hour meter. It had no idea what time of the day it was. And now we have both that outdoors, but indoors we have a prepaid meter where you purchase units of kilowatt hours and you punch in a code and your electricity goes on. But this prepaid meter is not connected to the internet or any kind of communication. So there is no peak and off peak. So how would they measure that in countries like yours?
They have a meter which is electronic, of course, and then it already built in this feature. So throughout the day, it's a standard calendar, so it does not change. It's all the time it changes. Let's say if it's from June to September, the peak hours start from 7 to 11. Then if you move to September to, I believe, November, then it changes a little bit. So that's fixed. So that's pretty much built into the firmware of the code of the energy meter, and the energy meter has buttons, so you can even see how many units you used in the peak hours and the non-peak hours, and then they take their pictures, and you on the bill you see how many peak hours you used, how many non-peak hours you used. And now they install these net metering for people who have solar systems, and there you can even see how much did you exported, how much do you imported, and how much you exported during the peak hours and the non-peak hours. So it's a very comprehensive way they made to track energy. And recently, very recently, I think 2 months ago, they installed brand new meters which have 4G. So yeah, they don't have to come and take the pictures of everyone's meter reading. They just gonna send you an electronic bill, and I believe if you don't pay the bill in 15 days, the person comes and pulls a plug for your house. So that's how keeps track of everything.
I've had that happen to me by administrative error. The guy went to the wrong house. I couldn't really stop him, but luckily I knew enough about electricity to bypass his lock when he left and sort the problem out the next day. That was a couple decades ago, but since then our challenges have become more serious. Since about 2007, we started having rolling blackouts, intentional ones. They call it load shedding. So they shed some of the load from the network before the whole grid collapses because they hadn't maintained the systems as they should have, given the money that the taxpayers gave them. And it just got worse and worse. And by about 2022, it was about 2 hours a day. So I bought myself a big inverter trolley with two very large lead acid batteries and an inverter that wasn't pure sine wave. It was modified sine wave, but it should be good enough to last a couple hours a day. But as soon as I bought that, of course, the load shedding went up from 4 hours to 6 hours to 8 hours sometimes, and it really just destroyed those batteries. So to solve the problem, I had to get rid of that, go out and get a much more expensive lithium ion inverter trolley with the pure sine wave inverter, which I'm running through right now. So if the power had to go off, hopefully I would stay online. But just very shortly after I bought that solution, we had some elections here, and right before the elections, magically the load shedding dried up. So I'm not getting much use out of this expensive inverter trolley. So that's the challenge for me. And I would ask the chat to tell us about the power in your country, since we are discussing power challenges. What about where you are, Saad? I won't ask you, Clemens, because I know you don't even think about electricity. It just works there.
Yes, so I think the situation is almost absolutely the same. We do have load shedding as well, and since I remember, there's been load shedding since I was born till now. The area I live in now has relatively low in the rural and areas. I believe it's more load shedding, even more than 6 hours. And in the urban area, it's more programmed, but they have a structured, when they start load shedding before the election or after the elections, I believe that's I would say the season. That they give you a proper, there's a schedule, then you have to follow. Yeah, so likewise, absolutely the same. I bought the batteries. The batteries was too less, only 2 hour backup. Then I had to buy more batteries. Then the batteries, lead acid batteries, they deplete so faster, and then you have to check the water, and it's a lot of maintenance. And then recently, I upgraded my inverter, so the inverter is now a hybrid inverter rather than an on-grid inverter, and then it has a battery pack of 5 kilowatts. So now, and I routed everything to my computer and all the important stuff. So now I'm pretty much safe, but now there's no load shedding, as you said. And now I'm just waiting for the bad time to get it used. But the good thing about that upgrade is that now I can sell in peak hours. So what I do is I charge my batteries during the solar, during the daytime, and then during the peak hours, when the electricity is expensive, I deplete my 5 kilowatt battery. So I deplete it, I send some units to the grid, and that's how I keep. I think my bill is in negatives, so the government has to pay me, but they won't, of course. Uh, I'm trying to keep a balance this way. But of course, it always helps during, let's say, if there's a lot of rainfall, sometimes a transformer blows up. So at these times, you really need a backup at that point, and I think that's a little bit. I'm on the safe side in that area.
Yeah, funny story actually. When you get used to the kind of load shedding that we had, we were watching TV a few months ago, and all the lights went off. So we were like, this isn't even scheduled load shedding. But I'm sure it'll come back on soon. And we waited and we waited. We went to sleep, and the next morning the power was still off. And then I looked out because it wasn't sunrise yet, and the lights in the parking lot were on. So I checked my distribution board. Something had merely tripped. I could have turned it back on the night before, but we just took for granted it's the government doing it. Good point from.
I had almost
Yep.
I had almost the same situation when I was upgrading my solar system. So the thing was that I had everything on the UPS. So the important stuff like fans needs to rotate in order to keep you cool. And when we moved the breaker, we moved the system and turned it on, the breaker flipped and we didn't know. And we were trying to guess which wire was it. I was questioning my capabilities, everything. And then after half an hour, I went down, opened the circuit breaker box, and okay, one breaker flipped. And I think we need to keep checking it, because then otherwise it would have been a big problem if I didn't check it and I tried to route it the other way. So these things happen for sure.
Actually, it happened a few nights ago when just as I was about to start cooking, the power went out. But luckily, I was smart enough to realize to check the board. And indeed, one of the stove plates had shortened out. So I just had to not use that plate. And I just want to drop I think that's Kinet. I'm not sure how to pronounce that. But additional energy costs are often supplementary. Distribution, taxes, environmental contributions, and so on. Good point. And Jens, I know that the power is pretty reliable there, even though you're having trouble with the internet in Aachen at Elektor Labs. But I'll give a gap for you to answer. Do you have any power challenges in Germany? And if not, tell us about your going outdoors into the field and live streaming and the kind of power that you need to be doing that for hours on end.
Yeah, first about the power shortages, we also have from time to time a power outage. Yes, but it is very, very rarely a big region. It's more sometimes a street or something, but yeah, I also had to face these issues. And yeah, I have at home a battery. I bought it exactly for going out in the field. And I remember one power outage, I used that battery. It was a LED battery, a good old one. And yeah, I could at least power my laptop and my phone and so on, and I could work again. So yeah, we know that in Germany also, but it's very rarely occurring. And yeah, the power in the fields, yes. I can see I'm frozen again, but okay, I'm back. Yeah, of course you need power if you want to power equipment out there in the fields. And yeah, there are a lot of people using generators for that. I'm not a fan of that. Because yeah, I already have been on events and on a lot of places you are not allowed to use generators. So yeah, I think really electric batteries are better. And yeah, we started with batteries and inverters. And later we changed everything to DC voltage, because then you have really efficiency benefits.
Yeah, absolutely.
And yeah, at the moment we are powering everything, avoid ground loops and so on. Back again. Yeah, So that is the direction we are going at the moment, my friends and me. Power everything with an own small battery. Yeah, of course, I watched carefully one of the last lab talk shows where Thomas warned everybody to not let lithium batteries take dust in some corner. And yeah, I made a battery plan for myself. And I identified 60 batteries at the moment, not all lithium, but yeah, I really made a planning now and charge these. So that's maybe also a good idea for some of our readers. Yeah, and yeah, coming back to powering things, that is indeed a very interesting issue. So when I was in Spain on holidays, I thought on maybe taking with me very small power banks, and then you can take these to the plane. And then I had the idea to maybe put them in series, because for a small amplifier, and if you, for example, want to make music at a pool or something like that, then it would be good to have 20 volts. But okay, Saad is now saying that is nearly impossible. But okay, maybe we can find a trick or some. It will raise another nice article. So yeah, that's everything I can say at the moment about power.
Well, thank you for that, and I will continue here. We've got a bit of a gap in the conversation because Jens takes a few seconds to hear me, so I have muted you now, Jens, and I see Saad is back with us, and we have talented engineers in Saad and Clemens, so if you need a solution, they can find one. If you need to get 20 volts from 5-volt batteries, I'm sure it can be done. Let's go back to our giveaway, as we do always at about this time in the show. I will tell you the giveaway code word now. If we could get the banner on the screen to give you the website address. You can also see it if you've got a nice big screen, but there it is. elektormagazine.com/Elektor-Lab Talk-giveaway. And the code word for today, I've chosen amber because from rubbing amber to swiping glass, how humanity turned electricity into electronics. That's Clemens's latest book. And like I said, it's like he said, it's not a comprehensive guide to how a valve works, but very important first principles for those of us who maybe didn't pay attention in first principles class because we wanted to jump straight to ones and zeros. So good luck, everyone, to enter the competition, and good luck to the winner. The rest of you, I'm sorry, you'll have to buy it. Frank de Hout says, very few outages where he is, less than once a year if there's one, and only just a few minutes. Yeah, I had Clemens's luxury back in the 80s where we never had to think about the electricity supply. It was just always on, and if it went off, that was such a cool novelty for us kids. Although one night we had a serious blackout for a few hours, the whole night in Johannesburg, and the next day it was newspaper headlines, front page, and they had a photograph of Johannesburg the night before, but it was a bit of a joke because the photograph was just a black picture with a big headline about the power blackout. Shall we move on from power? Start to one of your other favorite articles. That was the USB measurement adapter, which is also coming up in the circuit special in August. What drew you to this one, this article by Alfred Rosenkranzer?
Yeah, it's a really good article. So it's basically like a little debugging testing tool between your PC and a USB device. It lets you measure current, both in static and dynamic, and you can use your oscilloscope to check the USB data lines. Yeah, it also has, I think, disconnect power jumpers if you need them. You can externally power the USB if it requires more current. So it's a pretty comprehensive, nice little tool which you can use to test your USB devices. I
Nice.
honestly like it because I bought 3 chargers from AliExpress, and yeah, I want to check out if the voltage and the current is stable or not, because on my phone it disconnects and connects A very like rarely, but does happen throughout the time. So I want to see what's the issue.
And I see this one, unlike the last one we spoke about, does have data lines connected, but they pass straight through. They don't do anything in the circuit, except they go to this high-speed probe here at jumper 2. What is that for?
Yeah, so yeah, basically what you can do is that high speed probe, you can put your oscilloscope there, and then you can read the USB signal passing through. So sometimes if like in your computer you connect a device and it says unrecognized USB device, and you want to find out whether the USB protocol is working or the communication is happening or what's wrong. So that's how you can use it, this probe for.
Okay, great. And I see there's also a place for a current probe here at jumper 3. So
Yeah,
that looks like a pretty handy circuit. Nice and compact as
indeed.
well. And then over and above what we've already published, let's talk about what we've got on our desk. What I'm working on right now, I've got a few Raspberry Pi Pico 2s here. Don't know if the camera will focus. Those are still in the package. This is one I've soldered headers onto. So the idea is I'm trying to get edge impulse to work on this so that it will recognize a wake word, your own wake word, so you don't have to say, hey, G word, Google. I'm not saying the word because I don't want to disrupt anyone's home if they have such a device, or the one from Amazon either. But you can make your own wake word using edge impulse. This is not the most powerful device, but I believe it can work based on the research I've done online. So you could say, hey, Elector, or Elector, turn off the lights or that sort of thing. So I'm trying to get that to work and find some nice use cases for it. Another one is I've got this WaveShare GPS 4G hat for the Raspberry Pi. So this is for a museum that needs to have a video kiosk always playing videos. So they do have Wi-Fi at the museum, but they want a backup plan. So if I just take this out of the packaging, this is the hat here from WaveShare, and it gives you GSM and GPS. Now we don't need the GPS because we know exactly where it's located, but it does come with a GPS antenna. And of course, nice external antenna here. And the idea is it will be mounted at a museum, connected to a TV, playing a loop of videos, either on shuffle or in order, depending on what the user wants. Okay, and you can control it from afar. So the guy who's maintaining the videos, who wants to change the videos, he doesn't have to go into the museum, plug in a USB stick and go through all that hassle. He can just connect remotely from it to it and upload and delete videos at will. But he also wants to be able to do it via the cellular network. I'm not sure that's 100% necessary, but that's what he wants. So I'm helping him out with that. That's on my desk. Clemens, I believe you've got something that's upcoming.
Yes. Oh, here it is. At Elector, we always try to do something for Christmas. And the problem is with Elector is that we work really way in advance. So we are already working on the December issue. And
2025, I hope.
Yes, yeah. We're not that far away. So the problem is always that when we want to do a Christmas project, we start thinking about it just too late. And so this year we started early, and I managed to get it ready for the upcoming December edition, which is of course really surprising, but it is a Christmas tree. Now, I'm sure you never have guessed that. But it's actually a 3D Christmas tree. So this is a prototype. I'm still trying to make it better. This Christmas tree is a sandwich, and on the rear side are addressable RGB LEDs. The front side, I used the PCB manufacturer's cutter to write the words inside in the PCB, so to cutout to engrave the words in the PCB. They didn't like that because I took a lot of time from their pooling service, but they did do it in the end. And so then you can stick it on a Raspberry Pi baseboard, which then controls the LEDs and lights up the words. So you have in several languages. It's hard to see, but we have.
I see it.
Here we have.
Christmas,
Let me see, Weihnachten and Frohe. Here we have Frohe Weihnachten there. And we have Merry Christmas, and it's in French, and in Dutch, and in Spanish, and Italian, and even in Danish, because I had space for one more language. So that's what I'm working on. I just discovered a mistake in my baseboard, on my backboard, my rear board, so I have to fix that. And then it will be hopefully a nice kit that you can build for Christmas. My wife already claimed the prototype. She wants to have it in her on her desk on her work during Christmas. So I will have to make a second one.
Yeah. Now, last time I made circuit boards, all they would do is drill holes at defined components. How'd you get them to make special fonts on that with holes?
Yeah, well, I had to draw that myself in the cut out on the board outline layer. I wrote my text, and because there is a lot of it, it slowed down their production process, and so they made me pay a little bit more for the board. But yeah, actually, they just cut out whatever you put in there as long as you reach their specifications. So it's I think 1 millimeter width, and you shouldn't make the traces too short. And of course, for letters like an O or an A, where you have something in the middle that you don't want to fall out, you have to make sure to keep small small bridges on the PCB so it stays there. And for accents like Noël in French, you can just drill a hole. Yeah, and then do some drawing on the silkscreen layer. So it's not very high tech, but it shows how you can have fun with PCB manufacturers.
With the manufacturers and the manufacturing.
Yes, and the machines, and because they just do what you ask them, and they.
Well, I have to
if it's
ask.
too complicated, they just ask for more money.
You said it was a bit annoying for them, so they did ask for more money. But that was a prototype. How do you envision putting that into mass production if you want to sell it as a kit, for example?
Well, then you're not pooling, so I don't know. They will define a price for the board, and then if you make 1,000 boards, then you're not pooling anymore. So it's a different process. Maybe they refuse, and then we won't have a kit. You could also, the front layer, it doesn't have to be PCB material because there are no traces on it. I just use PCB material to make a whole green material Christmas tree. But you could replace the front plate by even by wood or by acrylic, laser cut it. That's all up to you. But yeah, I went for the PCB option.
Great. I want to go back to Jens now. I've realized the trick to letting Jens talk is to give it a few seconds after I've finished speaking. Just like back in the old radio days, I have to speak and say over, and then give him a chance to speak and not interrupt. And then when you're done, Jens, you can just stop and we'll wait a few seconds. Or you can say over or over and out. I want to go back to your favorite article here. It's the ESP32 audio transceiver board. And this was by Saad and Jens. So you guys are the contributors on this. Could you tell us a bit about that, Jens?
Yes, of course. Yeah, you can see here boards, which is versatile for many audio applications. But you can also use it for data logging and measurements and so on. It's based on the ESP S3, which is a powerful variant of the ESP32. And yeah, you have their connector for plugging in I2 audio module, so to say. It has a DAC and an ADC, so a DAC and an ADC on it. and it's connected to the ESP32 with I2S. So you can input and output music. And on the other side, you can plug on the Nordic NRF24 module. So you can send data, but you can also send audio. And this is actually the first article of a kind of small series where Saad and me are presenting the board itself, the circuit with all connectors. You have many options to connect it to other modules, sensors, and so on. And yeah, it also has an SD card on it. And we did not want to end this first article without a real application. So I developed a very small demo where WAV files can be played from the SD card, and you can output it to hear music. So it's a kind of music player. And here on this photo, you can see that board in action, but that is already part of the second part of this series. You can see all the modules on there, and we built it in a metal housing. So that has a reason, because this application is already showing outputting audio, transmitting audio to another receiver. So you have a wireless connection between two of these PCBs. And here, Brian, you are switching very fast. Yeah, we will report on the wireless connection extensively in the second part of the series. I'm currently working on it. I'm currently finishing it. That will be in the September-October edition. Yeah, and that's actually my pet project, or the pet project I'm doing with a friend. You can see here Alps motor potentiometer, and there's control circuitry, and as you can see, that is a very early stage of prototyping. So we are using a lot of modules, and we are using an ESP32 with that compact Shio form factor and some grove connectors. You can see the loose cables, and at the top of this picture, you can see this is a subwoofer preamplifier. Yeah, and currently I'm working on a better PCB for that, because on that PCB there's an ESP32. There's also a dip switch. You can see an external ADC, and you can see a motor driver, and to integrate that a little bit better. And yeah, I have the second revision of that project on my desk, but I don't want to switch on the webcam. I think then internet will explode. So maybe I can show it here in the camera. There's a second integration stage where I'm using distinct dip switch, and I made a small piece of Vero board with a port expander. If you have, if you don't use, so to say, ready-made modules with these connectors, for example, from Seed Technology, you can also save some euros. Of course, if you buy only a breakout board at Far East, then you can get it really cheaper. So, but yeah, we would like to integrate, of course, everything at the end on a PCB. And yeah, that is the way of developing. Always another round and always another idea, and you never come to an end. I think everybody of us know this.
Yeah,
And coming back to the wireless edition, I have a second. I have a second board here on my desk. Brian, back to you. I think you want to say something.
no, I thought you were done. I'm sorry, it's that delay again. It's a very versatile board with a lot of different features, and you've chosen to go with audio. So you needed to give it a real-world use case. But I'll ask Saad, with less of a delay here, what is the purpose of this over here?
Well, this is actually this is not the part of my project. This is, I think, is controlling the volume. Jens can shed light on this.
Yes.
Okay, so it's a volume control.
Yeah, maybe
Look,
it
it's
was
all-
a little bit confusing because these are actually two projects. So the first project is this versatile ESP32 audio board. We called it audio transceiver board, and what you are showing now in the image is actually my pet project. So yeah, I made a labs page for it, but yeah, actually I reported on that small PCB with the motor potentiometer in the last circuit special, but the rest of the circuit is not reflected in an article yet. But okay, you are right. On the left, you see an Alps motor potentiometer, and yeah, that is actually just a replacement of a mechanical potentiometer. And yeah, you need to drive the motor of the motor potentiometer. You need some motor driver module. Then you need some ESP32 to control everything. And you have a Wi-Fi connection, of course, to remote control it. And because we have more than one loudspeaker or more than one station, I use for all these stations dip switch. So you will just literally code the number of the station with dip switches. You could also do it in software, but okay, sometimes dip switches are quite handy. Back to you, Brian.
Very interesting. Yeah, I was looking at that and I was saying, it looks like a motor, but it looks like a potentiometer. What's going on there? So you actually turn the potentiometers manually. It's like those big mixing desks where you can pre-program the volume levels.
You
and
can
see the sliders go up and
can
down.
actually, yeah, actually you can turn these Alps motor potentiometers also mechanically. If you put the axis through your housing, you can turn it mechanically, but you can also turn it electrically controlled by a motor driver. And then you can remote control volume. So actually, the whole circuit you see at the bottom is just to remote control a volume, yes.
Wow, very impressive. And speaking of impressive, well, we've gone up against an hour of the show very impressively, but we're not going to end it now. If you, the audience, doesn't have the time, you can leave now and come back and watch the recording. Clemens, by the way, I saw your cat. I just want to let you know that Chip Micro says, great to see Clemens again. And Clemens's cat, of course. I'll take one more comment here, and then I'll jump to Saad with what he's working on, what's on his desk. Practical Electronics says, thanks for this stream. In Tunisia, during heat waves, our company of electricity implements load shedding to prevent a total blackout. This is due to the growing number of AC units. Yeah, AC, especially in hot places, and it can get pretty hot here in South Africa in summer. But we were talking about how load shedding magically dried up, and I think it wasn't all to do with the government solving problems. I think it's a lot to do with people all across this country who are just really tired of it, and solar has exploded everywhere on shopping malls, on houses, and I think it's taken a lot of strain off the grid. So that may be part of the reason why we don't have as much load shedding lately. Now, back to Saad. We've showed what's on our desk, but I think you've got a pretty exciting project that you're working on. Tell us about that.
Yes, so I'm working on this SO Arm 100. It's designed by Robot Studio with the collaboration with Hugging Face. So these are two robot arms. This is the leader, and the down here is the follower. The main difference is that what the leader does, the follower mimics it, and then you have this camera system to train the AI to do it by itself. So basically, let me just move to the second screen. So yeah, so this is the leader. I mounted it with the F clamps. You can basically download the model files and then 3D print them by themselves. And the servo motors, I got them from Seed Studio. And the printing of this entire arm was done by 3D print service here. Not the best 3D printing out there, but yeah, it gets the job done. The robot moves, and that's more important, not the quality. Yeah, so coming down to the setup. So basically, for AI to function and to know what's going on, you need a really clean setup. Um, and good lighting. There shouldn't be no shadows, no hard shadows. Right now I'm still having shadows, but it's not very optimal. Yeah, so I have a lot of lights, a light bar at the front, there's a ring light, then there's a camera. The camera I'm showing right now is the Overwatch camera, which sees the entire situation happening on this plate, or this wood plank. I have everything screwed down to the max because these arms, they tend to be really scary when you plug them in for the first time. They move in such a way that they're going to destroy something, but you need to be careful. Make sure you're very away from it so it does not destroy anything. Yeah, so moving on is, yeah, this is another angle of the camera. So for hooking everything up, you have these screws and these servos, and that's pretty much it. You don't need anything else. In the Suit Studio robot kit or the servo kit, they they include the servos, but not 3D printing parts. So that's, you need to be careful about that. But I believe now they're shipping with 3D parts as well of the arm. Assembly process is very simple. There are a bunch of videos out there to show you how to assemble it. But I would say a word of advice is put tight every screw, and don't screw up the I would say steps. There are two, three parts which are similar, but if you replace them, then the wiring process gets a little bit tedious. But it's a foolproof arm. Make sure you get fasten the servo in these small sockets of the arm, because at first when you're assembling everything is nice and tight, but when you start moving it, using it, the servo warms up, and then of course the material expands and this gets loose. I experienced it and I thought it's not going to happen, but it did. So then I had to fasten it everything with screws. Yeah. So talking about the cameras, the first camera you saw, the second camera, I wanted to have a very light camera, which I will show at the end what it's like. So it's a Cortex camera, which is focused on the gripper of the robot to see whether it picked up the object or not. And I basically bought this cheap camera, but the housing was heavier than its PCB. So I just took it out the housing. And then this is the camera chip. And then I made a 3D model in order to mount it at the front of the gripper. So it has a nice Cortex camera which can see which is seeing the gripper, whether it's holding the cube or not. So this is another image of that. And then we have this, so how to control the robot arm. There are basically 2-3 ways to do it, but the most simplest way is using a Phospho. Phospho is an AI company, and yeah, they make this sort of stuff to control your robot arms, not for this one, but also other ones as well. Here's a small video of what's happening. It just picks up the cube, places it in, and it's actually recording everything. So both camera feeds, the servo angles, and at the end of the video, you will get an idea what is happening. So this is how it gets learned. You almost basically do 50 sessions with you picking up with the leader, the cube, placing it in the tray, and then picking back up, and then stopping the entire session, and then starting it back over again. So you need iterations in order to train the AI model. And at the very end, you can see the everything in action and the recording and yeah, it took me an hour to reach episode number 26, and I have to do 25 more. So it takes quite some time to train these things, for sure.
And when you say episode, what does that mean exactly?
So one episode is these 4 cubes on the table or on the surface, and then you pick them up and put them in the tray, and then you make another scenario. You put the cubes at a different angle, so at different places. So basically, then all these episodes and all these video feeds and all these servo angles gets via machine learning. Um, the AI gets trained to pick up the cube by itself, not being controlled by me, or making the leader by itself. It picks up the cube and puts it in the tray. So it's more of a training process. Just like I would say machine learning process for voiceover. So if you say, hey, Elector, many times, it will learn from your voice, and you can change your accent to make it even better, maybe different voices. So the main thing about AI is that you need to have a very diverse data set. You need to have a lot of data set as well, and different situations as well, so that it can learn and connect the dots with this neural networks. Here is a side view of what happens on the side while I'm controlling it. And yeah, a good setup is like everything is good. There's no tangles whatsoever. Nothing is falling apart. Because I have one video to show you, which, where things don't go as expected, for sure. So this is where everything is moving nice and smooth. But if things are not working nice, then there's a bad take. And here, everything was jittery for some reason, and I had to turn on the gravity mode to fix that. It's basically a setting in Phospho.
Are you going to show us a demo of something going wrong?
Yep, it's about to happen. I have to build up, Everything is working fine. So if you there you go. So the camera dropped from the top because it got tangled from the USB cable. So these type of things will happen, but we need to take care of it. As you can see here, I have these cross marks to keep the camera setup as same as possible for all the episodes. Because if it falls in the middle, then I have to retake, and then I have to keep the camera angle the same again. So this is pretty much it. Ryan, you can continue. I'm done.
I'm just watching this with fascination. I was hoping something more would go wrong. Watching with
there's only one bad
Schadenfreude,
take.
if you will. Will this be on? Have you put this on Elektor Labs, or are you planning to?
Oh, currently it's in. I'm making this project. So once it's done, of course, it will be on the Elektor Labs for sure.
Okay. And speaking of that, let's take down your screen. We've got a question here for you, Saad. Is the robot project just a test of product concept, or are you building toward a real world application?
Well, yeah. Right now, it was based on the same idea from the movie Iron Man. So he has this robot called Dummy, and it picks up the screwdriver and gives it to him. That was the vision. But now looking at that, it's a little bit where I'm a little bit far away. From cubes, I have to move to a screwdriver, and then from the screwdriver, I have to find a way in order to get my voice recognized and then translate it to finding the screwdriver and then picking it up and give it to me. It seems like it is possible, but at this moment, I'm a little bit scared to have it on my desk while I'm soldering, and then I'm asking, hey, please pass the something, and it just ruins everything with its whip. So that wouldn't be the best use case scenario. And that's why you see in industries you have a very clean space and a robot working in the middle and no one's getting close to it. And that's the very reason, because yeah, there's this factor of something when goes wrong and goes terribly wrong. So yeah, but yeah, it's in progress. Hopefully it might have a use case of setting my desk, keeping my desk clean when I'm away, because it gets untidy after doing one project. So maybe it can take care of that, but
Now,
we'll see
there's a
about that.
practical application. I have a similar question for Jens. I've got a couple of questions, so let me not pause, and then Jens will think it's time to speak. Speaking of Elektor Labs, Jens has published that one project of his, the ESP32 audio and IoT board. And just to remind our audience, this is a community platform, so if you've got any interesting projects, you can go there and upload them and give us all the details. And there's a lot of projects there, and we check them out regularly, and if we really like them, sometimes they get published and we can make a deal and a contract with you, and you can find yourself published in Elektor magazine. But two questions for Jens. One is from Chip Micro. It's a similar question to what I just gave you, Saad. What are you going to do with the audio project? First question. Second question from me. Why did you need your potentiometer to move motorized as opposed to just like having digital control?
Yeah, the first question, what will you do? Yeah, we are actually using it. So that is a private application. We can make music in the field with different loudspeakers, and every loudspeaker has his battery, his amplifier. And we are also transmitting the audio wirelessly to all these loudspeakers. So yeah, that is actually a project we are already using, my friends and me. But yeah, we are on the way, and one milestone is to replace our analog wireless transmission with ready-made modules by a digital audio transmission. And that actually raised a little bit that ESP board I reported on some minutes ago. But yeah, you can do also other things with that. So, but you can imagine that making really stable wireless connection, that is not a thing you can do in a weekend. So yeah, I'm actually working on that. Starting a little bit as a beginner, but I'm working on that now for weeks or months, better to say. And yeah, I would also like to ask the audience or everybody who sees the project to send me hints, maybe feedback, constructive improvements, ideas, and so on. So I know that there are people who are far better experienced than me on digital audio and maybe also wireless transmission. So maybe you can also contribute. I would like to have some feedback. And yeah, I can promise in good old Elektor tradition, we are really publishing everything. So my friend already, he built some step models or 3D models for a 3D printer and so on. And we will publish everything on GitHub. So it's not closed. Everybody can build then these amplifier stations himself, 3D print and so on. So yeah, I hope for other participants contributing to the project.
Great.
And there was the second question, why
did you need to have the remote,
Brian,
volume control motorized?
Yeah, because if you have 4 independent loudspeakers and you don't have wires connected, then you would have to go to every loudspeaker and turn up the volume. So that is, if you have 4 loudspeakers, then you have to go around and configure everything. So if you have a remote control, you can do it centralized. And of course, you can can switch the stereo balance and so on. So yeah, that was the reason.
Yeah, I suppose that makes sense. I have seen power amplifiers with volume controls that move motorized. Mine doesn't. We have to turn the volume up and down with the remote control, but the potentiometer is just a forever scrolling thing, so it doesn't have that kind of tactile feedback. But yeah, we have gone through an hour and 18 minutes now, and I thank everyone for staying with us. We still have 200 people live on air now, which is a lot more than we had registered at first. So you've been joining us as the show goes on from all different platforms, YouTube, Instagram, and from all over the world. We've seen the US, we've seen Belgium, Germany, and Tunisia, for example. So thank you everyone for joining us. Thanks, guys, for staying the extra 20 minutes because I know you've all got a lot to do. Like I said about Clemens, he's been very productive this year. He's put together this Neon Lamp Dice and he's published a book. And now he's got a Christmas tree to go and work on. So I've been keeping him too long. I've been keeping Saad away from his robot arm, which is lonely. In the end, needs to get back to his audio projects and magazine editing. So thanks a lot for joining us, guys.
You're welcome.
And I know
My
Jens's
pleasure.
response will come in a few seconds. And that brings us
Thank you,
to the
Brian.
end of Lab Talk number 36. Thank you so much for joining us, whether you came for all the clever circuits, the neon glow, or just to see what's on our desks. If you missed part of the show or want to watch it again, don't worry, the full recording will be sent to everyone who registered. And don't forget the giveaway. People, as always, asking for the code word. It's Amber. And good luck to those of you who are entering. And big thanks to our sponsor, Peak System, and of course to Jens, Clemens, and Saad for sharing their projects and insights today. If you enjoyed the session, be sure to subscribe, check out the circuit special, and keep an eye on Elektor.com for more upcoming events. If you're watching this on YouTube, hit the like below as well. Until next time, happy soldering.
Goodbye.